Good morning. Good morning to every one of you, and welcome to the Abodo, the new Abodo series, designed for a community of architects, designers, construction industry professionals who are like-minded and interested in sustainability, circularity, and in generally looking after the planet. My name is DK. I'm going to be your MC for today. But our first speaker up is Lewis from Abodo. So let me give him a proper introduction, and then we can hand over the digital stage to him. So Lewis Marshall is the area manager in the United Kingdom for Abodo. In his role, Lewis provides technical support to Adobo distributors and architects across the UK, ensuring they have the knowledge and resources needed to utilize Abodo's timber effectively. Lewis loves building long-term relationships with construction professionals and believes in the power of sustainable, beautiful buildings to improve both our environment and our lives. It's great to have you with us, Lewis, kicking off this Abodo series. So the digital stage is all yours.
Thank you, DK. Pleasure to be here. Lovely introduction as always, sir. So let's get stuck into it. Abodo and the future of wood. So Abodo Wood is a family-owned business. It was formed in 2001 by the Gudsell family, and we've been modifying wood for about 15 years now. How did we get into this? This is a photo that Daniel Gudsell, the owner, took when he went on holiday in the Solomon Islands. Unsure if anyone here has been to the Solomon Islands, but this was taken in the capital, Honiara, where we could see these gentlemen hand packing a tropical hardwood into a container. And the observation that was made at the time was you can understand why they're doing this. However, ultimately, if they continue to do this small island's going to run out of their natural resource. So this got us thinking on a wider scale, why do we harvest these resources that are relatively limited? And if this is happening on a small island, this could be potentially happening on a wider scale. And you can start to see it now, for example, in Malaysia, which has traditionally been quite a large resource of tropical timbers, Meranti and Kerowin. About 5 years ago, they were harvesting approximately 4 million tons per year. And last year, the government reduced this down to 2 million tons per year. And you can start to see that things are playing out in a similar way, much like in the Solomon Islands. So with all that in mind, why do people want tropical hardwoods? People don't necessarily want to deforest tropical rainforests, but what they do want is a timber that looks nice, performs well, and is durable. So we were thinking here in New Zealand, we've got a whole load of plantation timber, and how do we transform that wood that is not stable, not durable, and unattractive to have all of these aforementioned properties? So on the back of that, we formed this ethos and we created this purpose for the business, which is creating a lifetime of beauty with tomorrow in mind. There's a lot of talk about sustainability and eco labels. Sustainability for me is pretty simple. Is there going to be the same amount or more of this resource for future generations? If yes, then it's sustainable. Or if there's not going to be the same amount or more of this resource for future generations, then it's not sustainable. This is a geographical map of New Zealand. I'm unsure if anyone in the chat's been to New Zealand. It's a beautiful country. If you get the chance, please do go. It's made of 3 island groups. It's a relatively new country in the scheme of things. Polynesians arrived by waka or canoe in the mid-1600s, and Europeans came over in the mid-1800s. And when the Europeans arrived from Northern Europe and the UK, they were confronted with an island that was heavily forested in subtropical rainforest. Trees had never been seen by humans before that were 1 to 2 meters in diameter. And the Europeans, naturally, they got quite excited when they saw this and they started felling the trees, and they did a pretty good job of it. They managed to deforest over 75% of what the landmass was in about 100 years. The wood was shipped back to the UK for the Royal Navy and other various use case applications. A certain amount of it was used to build New Zealand homes. 95% of New Zealand homes are built from timber frame, timber cladding, etc., much like you'd see in Pacific Northwest or Canada. And by the early to mid 1900s, we'd quickly harvested the forest that was in New Zealand, and we were busy making farms and sheep and cows, other agricultural applications that New Zealand's well known for. And the government was actually quite forward thinking at this point in time. And they saw, obviously, we can't keep doing this. And we needed a fast growing plantation species that was going to fulfill our requirements that we required back then. So they cast around the world to try and find some fast growing plantation species. And they found two species that they liked in particular. One was Douglas fir. Douglas fir actually originates from Pacific Northwest or BC. And the second species was radiata pine. Radiata pine's also known as Monterey pine. It comes from California. Sorry. Comes from California. And in its natural state, it grows in quite arid conditions, windswept beaches, and it's quite a gnarly tree. Today, we've got about 7% of our landmass, which is planted in radiata pine. And this 7% actually produces 3 times more than we can domestically consume as a country. So New Zealand is a great supply base for timber or raw material. 50% of the forests in New Zealand are FSC certified. Everything that Abodo wood does is FSC certified. However, it's not that difficult when 50% of the forests are FSC certified. Radiata pine is very fast growing and it grows about 28 cubic meters per hectare per year, which is very fast. I always like to draw comparisons to bamboo, typically known as super fast growing and super renewable. However, it's hollow, so it doesn't have a lot of mass on the bamboo. So from a fiber yield perspective, it doesn't yield that much. For every hectare of plantation radiata pine, there's 28 cubic meters that's being produced from that 1 hectare per year. That's almost like a truckload per year. And that's not the aim, that's not the end game for foresters in New Zealand. The phrase that they like to use back home is 40 cubic meters per year by 2040. And that's not by changing anything, it's just by optimizing where they're planting the trees, optimizing that initial 7% of landmass, increasing productivity by using the existing area. Why are fast-growing trees important? It's important from a carbon perspective. All trees store carbon as they grow, and really it's the speed that they grow that indicates how fast they store carbon. Radiata pine stores 20 tons per hectare per year, as you can see on the far right there. And you compare that to Siberian larch, which stores 1.4 tons per hectare per year. So if one of our challenges in the world today is to get more carbon out of the atmosphere, fast-growing wood is a great way to do that. Radiata pine's not special. All wood stores carbon. I'm just pointing out that radiata pine stores carbon faster than other species. There are other fast-growing species as well. For example, eucalyptus is also quite fast-growing. Compare that with something else that's commonly used, such as old-growth Siberian larch or old-growth western red cedar, and we're talking about 10 times quicker from a carbon perspective. I'd like to talk a little bit on age of wood and old-growth species. Right here on the left-hand side is a piece of western red cedar that was given to me by an importer of cedar in New Zealand that's commercially available. And what we wanted to do was understand how old this timber is. So we thought that we would take the sample to a tree ring dating laboratory in New Zealand. Now, I didn't know that there was tree ring dating laboratories, but there are, where they count the tree rings. And the piece that we're focusing on specifically here is the finger jointed piece on the right hand side, the chocolatey brown color. You can see all the individual growth rings. So after they counted them up, the laboratory ended up dating the oldest growth ring in that particular piece back to 1727. Bearing in mind that the oldest growth ring on this specific piece was a 25 by 150 mil sample, the indication is that if we were able to get a piece that was closer to the heart of the log, the tree could have been approximately 500 to 600 years old. Now, I love Western red cedar. It's a beautiful timber. It smells great, machines well, forms well, and it's durable. However, my view on this is that we can't continue to harvest trees of this age. It's just not sustainable in my eyes. And the alternative, of course, is a fast-growing plantation species. So how do we get a clear pine product or something that comes close to clear Western red cedar? We prune radiata pine trees. Why do we prune the trees? Knots come from branches. We cut the branches off at year 8 and year 12, and then the high quality sapwood then layers over the prune scars, and it creates this high quality sapwood band on the outside. As you can see here on this photo, you can see the end grain of the logs. You've got the defect core in the middle. That's the first eight years of growth. And then you've got the sapwood, high quality sapwood band on the outside. The low quality heartwood still gets used for packaging and pallets or fence posts, which can be chemically treated. But what we're after is that sapwood, high quality sapwood band on the outside. EPDs, I'm sure there's plenty of people in the audience today that have come across EPDs at some point in time. An EPD is a way to quantify both the volume that's being sequestered in a product and also the amount of carbon that's been emitted and offlet into the atmosphere. And it's been calculated to an ISO or an EN standard. Abodo's done EPD, or we have done an EPD on all of our product variants. Good for us. Wood products store carbon. All wood products store carbon. The question is how much carbon has been emitted to manufacture and process the wood into a durable product. For Abodo Vulcan laminated vertical grain, after the thermal modification, laminating, transport to and from the forest, and 21,000 kilometers of sea freight over here to the UK, we're still storing 420 kilograms per cubic meter of carbon. As I mentioned, our EPD covers all of our product variants, so Vulcan sawn, profiled Vulcan. It covers all of our product variants. The next question to ask is, how does that compare to other woods commonly used in the industry? We asked Callum Hill, who's an ex-Bangor University professor, to compare EPDs of other modified woods that are typically used in the window joinery space. In the red, you can see the amount of carbon that's been emitted, which is classed as the GWP or global warming potential. And in the green, you have the sequestered carbon from the natural wood, the biogenic carbon. So we submitted data for EPDs locally made in the UK, along with untreated kiln-dried radiata pine as a baseline on the very left-hand side. It's important to note that we found it quite difficult to source EPDs for a lot of products that are available in the UK in the market. One that we did manage to find was a locally made product called Brimstone, another UK manufactured thermally modified wood. And you would anticipate for a locally made product to have a lower carbon footprint than something made in New Zealand and being shipped halfway across the world. But as you can see on the screen, the statistics do differ. We suspect it's due to the energy use. In New Zealand, 85% of our energy is renewable, as well as sea freight being extremely efficient from a carbon perspective. Then you start looking at other modified woods, such as Accoya, which is commonly known. And we found that Accoya starts to have a carbon footprint that nearly starts to offset the sequestered carbon. For Accoya, which is an engineered modified wood, that has nearly 3 times the amount of sequestered carbon in the wood, becoming a net emitter of carbon. It's important to consider the carbon footprint of modified wood. Just because it's wood doesn't mean that it stores carbon. And what you need to consider is the amount of processing and carbon that's been emitted to manufacture the product. What Akoya would quite rightly argue is that they've made a very, very durable product, creating a product that's not going to decay and rot and return the carbon back to the atmosphere. There's a trade-off between the energy and making a product that's durable and getting that balance right. Thermal modification. On the left-hand side, we've got kiln-dried, sawn, radiata pine on the left-hand side. And on the right-hand side, you have this chocolatey brown, thermally modified radiata pine product. Thermal modification process, it's originally Finnish technology. The Finnish really pioneered in this space. Thermawood's been in the UK market for approximately 10 to 20 years. And typically Therma would thermally modify Nordic pine and Nordic spruce. We only use Finnish technology ourselves. The Finns had the bleeding edge of the equipment side. And these kilns are specially made and they operate up to 250 degrees Celsius. We have 3 of these kilns in New Zealand and we have 1 in Malaysia. Abodo's developed a specific schedule for radiata pine. The Finns have a different schedule for their own species, and it's important to make sure that the thermal modification schedule matches the relevant species. So what is thermal modification? The first phase for us is putting in kiln-dried sawn radiata pine into the kiln, and we get it up to our own magic number, which is 230 degrees. This process occurs at a rate of approximately 1 hour per millimeter. So 25 millimeter thick product is approximately 25 hours in the kiln, and 75 mil thick product is about 75 hours in the kiln. So we ramp the temperature up to 230 and we hold it there for 2 hours at a minimum. At this point, this is where the thermal modification process actually takes place, and there's a cellular change to the structure of the wood. The moisture content at this point in time is 0%. Then we recondition the timber with steam to around about 6 to 7% moisture content. This is where the wood naturally likes to sit now after the thermal modification process takes place. So at 65% relative humidity, 20 degrees Celsius, the equilibrium moisture content likes to sit at around 6 to 7%. Decay and rot require 2 things: warmth and moisture. Less moisture in the wood equals less chance of rot. So as an overview of the thermal modification, what actually happens on a cellular level, if you looked at the end grain of a piece of wood under a microscope, you would see that it looks like a whole bundle of straws compacted together. Rumor has it that there's actually a species of wood where if you cut a small piece, you'd be able to suck up water through the end grain of the timber. So on the left-hand side, you can see a green cell, and this is what the wood looks like when it's freshly cut, full of moisture in the cell and also in the cellular wall. In the middle here, you can see there is no water inside the cell, but there's still moisture in the cellular wall. When you're air drying a piece of timber outside in summer, you'll easily be able to get water or moisture outside the cell, but you'll always tend to struggle to get the water out of the cellular wall. So if we were to air dry a piece, over summer, the water inside the cell would evacuate, but the water remaining in the cellular wall would remain. What thermal modification does is when we heat it up to that high temperature of 230 degrees for 2 hours, we damage the cellular wall, so it can't hold as much moisture, and that's why it likes to sit at that 6 to 7%. The ability of moisture being held in the product has been reduced. So what are the pros and the advantages and disadvantages of thermal modification? So it comes out looking quite aesthetically pleasing, comes out that nice homogeneous chocolate brown color throughout the cross section of the timber. It increases its natural durability up to class 1. It now has enhanced stability. It's got less movement, more dimensional stability now. It likes to move less. Its thermal properties have been improved by about 20%. It's got reduced resin content in the product. So during that thermal modification process, it bleeds out all of most of the extractives and resins that are inside the timber. And that's good as well from a coatings perspective. Coating manufacturers don't typically like resins, as they tend to bleed out of the product over time. But during that thermal modification process, we bleed them out for them preemptively. We've got nice long lengths without knots because of the pruning that we did. And one of the downsides is reduced density and strength. So because we've lost some of the resins and extractives in the wood, it does make it more brittle. So it just requires some more care when handling the product and working with the product. Our warranty, so we got a 15-year warranty against all fungal decay, regardless of the species of fungal decay. But we tend to prefer to like talking about expected service lives. And to back that up, we've got our durability test report data. So this is an example of decay testing that we have back home in New Zealand. The photo on the right-hand side that you can see, we have pieces of wood that are sitting on a horizontal, untreated pine bearer, and test samples sitting on top at a 45-degree angle. This untreated pine bearer will rot and pass decay onto the end section of the test samples quite quickly. The untreated pine bearers will rot typically in about 5 years. We took some test samples of chemically treated wood commercially available in New Zealand as a reference point against our Vulcan timber. We've got chrome, copper, arsenic treated wood, ACQ, or Tenlith E as it's known here in the UK. And we compare them side by side, and that's the way that you can determine the durability of the timber. We did this test over the course of 11 years, and it was monitored by Scion, who's essentially like the BM Triada back home in New Zealand. Another way is to make 20mm by 20mm stake tests and put them in the ground in what's known as a fungal decay cellar. In this case, we took some Californian redwood heartwood and it compared to our material. So we ended up taking all of that data and we're starting to form a view of how durable our product is. And we submitted that data to a UK research facility, BM Triada, as we found it was quite important to have a UK perspective and opinion. And their opinion was that outside, uncoated, and above ground, Vulcan should last 30 years. And for coated, it would have an expected service life of 60 years above ground, out of ground contact. Casting your mind back to when I was talking about thermal modification recipes for specific species, Nordic spruce and Nordic pine have a slightly higher durability class of 3 and 4 respectively. However, radiata pine has a natural durability class of 5. When we thermally modify radiata pine at 230 degrees, we boost that durability to class 1. Thermally modifying radiata pine at the thermo-wood schedule, or 210 degrees, will not perform in an external environment and will rot relatively quickly. As you can see here, we took a sample piece of radiata pine thermally modified at the thermo-wood schedule and we submitted it to the BM Charter of New Zealand, Scion, and they've said that it shows relatively poor resistance to decay and should not be used in external applications. The reason why I'm talking about this today is just to try and differentiate our product against other thermally modified radiata pine products that are available in the market. Obviously, we've been modifying radiata pine specifically for the past 15 years now, and we have the most durability data and testing data for thermally modified radiata pine specifically. So we're just trying to separate our products out respectively. Dimensional stability in service is also quite an important factor, both in joinery applications and also in external elements, cladding and screening, for example. We went back to Scion and we gave them some commercially available samples for a swellometer test, which is where they take test samples, they measure them, and then they dunk them in water and they leave them soaking there for 3 days. And then they measure them after the 3 days, and you can see how much they swell. On the screen here, you can see a box and whisker graph. And the top and bottom line being the variability, and the thick black line in the middle being the average. So what you're looking for is a relatively compressed box with low amount of swell. We took radiata pine untreated as a base sample, our thermally modified radiata pine at 230 degrees, Hiboney, Akoya, Cypress lastanica, Victorian ash, Western red cedar, white oak, Eucalyptus grandis, Sapele, and Siberian larch. As you can see on the screen here, Akoya performed excellently, almost superhuman for a wood product or a timber product. Western red cedar also performed quite well. It's just important to note that we saw the sample piece of the Western red cedar, and it was quite a old growth, tight grain piece. Our thermally modified radiata pine also performed quite well. As you can see here, the swell was reduced from about 5% with quite a bit of variability to approximately 2% with quite consistent results. And as you move over further to the right-hand side, you can start to see that the swell increases along with the variability. I know I've touched on carbon emissions a little bit today. However, the other side of this is to talk about operational carbon. Thermal conductivity is pretty important as well, and that's related to the energy use in your homes. If you use windows and doors that have low thermal conductivity, it's going to keep the heat in for longer. Passive house or passive homes want to use materials that are the most efficient at keeping energy use at a minimum. Windows and doors typically being the weak point in the thermal envelope. Grain orientation is quite important. And as you can see here on the screen, vertical grain will always perform better from a dimensional stability point of view, and also from a surface checking or cracking point of view as well. As checking tends to happen perpendicular to the growth rings. If you cast your mind back to the photo of the radiata pine logs, we had the high quality sapwood band on the outside and a defect core in the middle. It would be really hard for us to quarter saw a tree to be able to get vertical grain storm product out of those radiata pine logs, and we would end up with a defect core piece on the end of each piece there. So what we've decided to do to get around that is by flat sawing out the sapwood band on the outside and face laminating these boards together into master flitches or blocks. And what we do then is we turn the block perpendicular and we cut through the glue lines. And this creates an engineered vertical grain product while also maximizing what we can get out of the logs. It also creates more flexibility from a design perspective, being able to generate larger sectional sizes as required, or even profiling down to a 10mm skin for internal paneling products. Some more photos of the blocks here. You can see them all stacked up. Also creates this aesthetically pleasing vertical grain orientation also. So what's achievable with our products here? So I'll run you through some of the product lines that we have that we're able to produce. You got Vulcan flat sawn out of the flat sawn material there. Vulcan vertical grain cladding. So out of those master flitches or blocks, we're able to run through the glue lines and create cladding profiles of different sizes. Vulcan vertical grain screening. So screening boards that are able to be used for privacy screens, louvers, internal linings from a 42 by 18 up to blocks that are 1 meter wide if necessary. Vulcan vertical grain paneling, so skinning down through the master block there, creating that 10mm skin, using it for internal linings, ceiling and wall linings internally, and also soffit linings, where cost becomes an important factor, but you want to bring warmth into the home. People typically tend to draw similarities to mahogany or walnut. Vulcan flat sawn decking. Shingles. This is actually a pretty cool product for us. We started doing it relatively recently, maybe about a year to a year and a half ago. We have relatively rough forklift drivers back home in New Zealand, and as I mentioned, the product does now have increased brittleness. So what we're able to do with damaged product is we're able to dock the product down and reprofile it and create a new circular product being Vulcan shingles and be able to reuse and reduce our waste. Vulcan vertical grain joinery. So this is a German joiner who's based in New Zealand now, creating European tilt and turnstile windows, where thermal conductivity is an important factor, stability in service, machinability. So joiners typically like to use our product because it machines quite nicely off the back of the planer, less sanding and less prep work involved as well. I'm going to cut to a video now, 2 videos actually. The first one being from the Baldy Carpenter. Fraser is a joiner who's been working with our product now for the past 2 years. He's based up in Scotland, and he's been using the product because of the aforementioned properties, as I mentioned before. And the second video will be from Catton Windows, a joinery firm who's based out in Norwich, who's been using our product for a little while now as well.
When the business first established its products in timber windows and doors, from the outset we realised we had to use a modified timber. After trying several modified timbers, we felt that Abodo was the best placed product to give us what we were looking for. Its environmentally friendliness, through to sustainability and its stability, it is the best product that we feel to give a quality product.
Abodo timber is not only stunningly beautiful, but it's also incredibly strong and durable, allowing us to create windows and doors that will last for generations. At Catton Windows, sustainability is a core value. We're proud to work with Abodo, a company that shares our commitment to responsible forestry practices. Together, we're crafting beauty and sustainability one project at a time.
So back in New Zealand, we like to take a holistic or a system-based approach, not just supplying a product, but supplying a coding system that we know is going to perform as well, along with the technical support to back it up. This is a little snippet from our website. The reason why we have these Watch Me Weather videos is, as the timber's quite a dark chocolatey brown color from that thermal modification process, when it gets exposed to the elements, it does tend to change quite drastically with exposure to UV and moisture, specifically lighter tone finishes. So these little videos are little time-lapse videos over the course of 12 months, and it gives an indication to the end customer that they know how the product's going to weather over time. Over here in the UK, we thought it was pretty important to have a UK-based perspective again. So we reached out to the 3 leading coating manufacturers here in the UK, Remmers, Sikkens, and Technos. And we've been working with them quite closely to build up some specifications, and these are now available on our website. So what's possible with our products? So I'll run you through some projects. This is quite a cool project for us. It's based up in Scotland, and we don't really have any heritage sites back home in New Zealand, as I mentioned. It was formed relatively recently, or it's a new country. What they decided to do was use the Vulcan vertical grain cladding and a black finish, Nero finish on the external linings and some screening, along with some Vulcan vertical grain paneling on that little alcove there. And it looks quite stunning. The contrast looks beautiful. Rumor has it he's actually a rugby player, and once he heard that a New Zealand-based cladding product was coming to the UK, he thought it was going to be the All Blacks of cladding. It's a cool job over in the US, in the Rockies, quite an alpine environment, quite dry, also quite cold. As you can see here, it's quite a large project with some larger sectional size cladding boards as well, 50 mil thick by 300 mil wide. They decided to use on their cladding boards. And as you can see there on the photo on the right-hand side, they decided to do a mitered corner where stability and service was obviously quite an important factor as well. This is an ex-All Blacks owned home, John Kerwin. This is his private residential address. And he decided to use the Vulcan decking, Vulcan flat sawn decking there on his project. As you can see, this photo was taken about 3 to 6 months after it was initially installed. And you can see the timber starting to silver off quite quickly. He's just left it uncoated just to naturally let this do this with grace. Greys, they're quite a popular finish as well, as you can see on the left-hand side on the sectional garage door. Once the timber silvers off, you're left with the pigmented coating that's penetrated into the timber. Almost like a semi-weathered finish, if you like. It's a job in the Hamptons in a specialist COX coating. Decided to use the Vulcan vertical grain cladding on the cladding space and open grain screen, and as well as the roofing element. The job in Australia, in Brisbane. I'm not sure if anyone in the chat's been to Australia, but one thing you will know for certain, it does get quite warm, up to 40-degree heats in the summer. They decided to go with a dark black finish with relatively high exposure, no eaves protecting the cladding. So they decided to go for the Vulcan vertical grain cladding, where stability and service was quite important. Don't want them warping or cupping over time. Internal linings and ceiling linings here, just coated in a clear just to really pop the grain out a little bit of the timber. The job in Queenstown, back home in New Zealand, decided to use it on some screening elements and some defeat linings. Beautiful spot. If you ever get the chance to go to New Zealand, Queenstown is one of the places to go. Very scenic. Some darker finishes here as well. This is quite a cool project. It's a passive home builder's own office. So I believe it's the first passive office within the Southern Hemisphere. So they use the Vulcan vertical grain joinery for door and window elements there, as you can see. Some lighter finishes as well. This is our own show home in Cardrona, which is a relatively alpine environment. It's probably one of the harshest environments back home in New Zealand. It's very, very close to a ski field. It's in the South Island. What we decided to do on this one here is use Vulcan timber as much as we possibly could, as you can see, on the open rain screen elements, the fencing elements, internal rafters, internal linings, and even the kitchen. You can't quite see the kitchen there, but even on the kitchen elements, really just to test the product out, put it in the harshest environment, see how it will perform. And it's been up for about 5-6 years now. This is a Māori university back home in New Zealand. The pattern on the external there on the facade is meant to replicate the weaving of flax, or kete, as they called it. Obviously, dimensional stability is quite important on this specific project as well. You wouldn't want the Vulcan vertical grain screening to be warping or twisting or cupping. Thank you.
Thank you, Lewis. Really appreciate your presentation there. If we can ask you to turn off your screen share, turn off your video so that we can fire you some questions, if that's okay. And I can also take the opportunity to remind the people in the Livestorm chat and experiencing this to utilize the chat functionality. I've already got a couple of questions for you, Lewis, from the chat. So usually I play my MC privilege cards and ask the first questions, right? But we've got a couple of questions. I just thought I'd jump in, and I'm just going to jump in with some questions and quote people. So we got Craig Simpsons here asking, what Euro class do the Abodo products meet, and can it be used with fire resistant coatings?
It's a very good question. The coating, or the fire rating class, sits at D as it currently stands. D, I've forgotten the last two letters. S, I can't remember the last letters. I know that it's D. But can fire resistance coatings be applied to the product therefore after? Yes, they can. We do have one testing that we've done previously with Centrin FRX. We are still working with fire retardant coating manufacturers to try and see what else is possible. But at this stage, we've only got the Centrin FRX.
Brilliant. Thank you, man. I'm going to jump again into the chat. Steve Jones is asking about the durability and how that compares with other products when it comes to specifically in years.
In years, so durability class rating sits at 1. In terms of expected service life, you'd expect to get 30 years or more if left uncoated, or 60 years or more if you were to coat and then, of course, maintain over the years as well, following the coating manufacturer's recommendations.
I think this question was answered, but I'm going to give you an opportunity to reiterate that. I can kind of remember in some of the graphs about the, we got a question from Dennis asking about important to the UK has an increased carbon footprint. So how does that work as a sustainable product then?
Sorry, would you mind repeating the question, DK?
Yeah, for sure. It was a question around important to the UK has an increased carbon footprint. So how does that work as a sustainable product?
Yeah. So we did an EPD on all of our product variants. The Vulcan vertical grain, which is the product, probably our most intensive product thus far, is still storing 420 kilograms per cubic meter after all of the freight, sea transportation, thermal modification, all of the processing. It's still storing 420 kilograms of carbon landed into the UK. I think it's actually landed into Rotterdam, but Rotterdam is further away than the UK. So, yeah.
Definitely. And I am going to play my MC privilege card because we're coming up to time here. And there's going to be a couple of questions in the chat that we'll pass on if we haven't covered it. But basically, the question I had is, obviously, you're representing Abodo here in the UK, and I'm really interested in how architects, architectural designers, other suppliers are reacting to the product, and what usually is the reaction about the application, where they get excited about the use of this product.
Yeah, for sure. I mean, it's interesting. I mean, a lot of people see it as a relatively new product here in the UK, which it is in the UK. We've been using it in New Zealand for quite a number of years. I think the use case application, people get excited by the different design, what's possible in regards to the lamination of the product. It's able to increase the design possibilities in terms of screening applications, cladding applications. Yeah, I think that it's been received well. I think it's more about just getting the brand awareness out there thus far. So it's still new to everyone, but I feel that the more that it gets out there, the more people get excited about it. It's been really cool so far.
Totally. And I was going to ask you a kind of a future question as well. One popped up, but what's the future in terms of product ranges, product applications? Where do you see Abodo kind of doubling down on, but also where do you see other uses?
I mean, specifically so far, we've been focusing on obviously the architectural market for cladding, screening, window doors, and joinery. That's primarily where we've been focusing. Can also be used for decking as well. I mean, it's got endless use case applications, but that's primarily what we're focusing on. Obviously, it's got no chemicals within the product, so internal applications as well. The only thing to take into consideration, of course, is fire, and we are working on that. So it'll be an exciting time ahead.
I like that, a little teaser there. Watch this space. Well, Lewis, thank you for your time this morning. Really appreciate you sharing your insights. Obviously, I'll put up the contact details a little bit later on, but it's wonderful to have you with us here to kick off the Abodo series. Thank you.
Thank you very much, DK. Appreciate it.
Cheers, man. Well, thank you to Lewis for kicking us off, but let's get straight into our next presentation, which is from Ortex, and we have Emma, hopefully, to present to us. I'm just going to double check that we can hear Emma and she can hear us. Just good morning, Emma.
Morning, everyone. Hi.
Wonderful. We can hear you coming through wonderfully. So I'm going to set you up in a lovely presentation, then hand over the digital range to your good self. So as you just hear, we have Emma here. I just mentioned she's from Ortex Acoustics, and she is an A&D consultant at said firm based in their London office. With a background in textiles and lighting, she brings a unique design-led perspective to acoustic specification. Emma collaborates on a diverse range of products and empowers her clients to reduce the industry's environmental footprint using Ortex Acoustics' innovative wall and ceiling products and systems. It's great to have you with us, Emma. I'm really excited to hear what you've got for us and what you're doing with Ortex. The digital stage is all yours.
Lovely. I'll just share my screen now.
Thank you.
I hope everyone can see that. So thank you for attending this presentation on how, as a sector, we can tackle the issue of embodied carbon and help build a low carbon future. Over this presentation, we will look at the following topics: the mechanism and impacts of climate change, the targets in place to limit its danger, and the role of the building sector, the importance of embodied carbon emissions throughout a building's life cycle and in building materials, how low carbon and carbon neutral materials can be produced, roadmaps for designers and manufacturers to achieve net zero by 2050, and finally, design considerations for reducing whole of life embodied carbon. So, as you all know, guys, we are currently facing a climate emergency. The Earth's atmosphere has more carbon in it than any point in the last 3 million years. The amount of carbon in the atmosphere is directly correlated with the average global temperature. So since the start of the Industrial Revolution, the concentration of CO2 has increased by almost 50%. Average global temperatures have increased rapidly in the last few decades, driven largely by economic and population growth. The concentrations of CO2 and other greenhouse gases in the atmosphere are unprecedented and in our history. So, what are the sources of these emissions? The vast majority come from the combustion of fossil fuels and land use change from agriculture and forestry. This chart that you'll see on your screen now shows the total global emissions by sector. Energy-related emissions make up the majority, This includes transport, energy used in industry, and energy use in buildings. CO2 emissions have risen rapidly as countries have developed, but they are yet to reach their peak. The 2015 Paris Agreement's goal is to limit global warming to a maximum of 1.5 degrees compared to pre-industrial levels. By limiting global warming to 1.5 degrees compared to 2 degrees, the number of people frequently exposed to extreme heat waves would be reduced by 420 million. The probability of drought would be significantly reduced, as would the risk of flooding, extreme weather events, and sea level rise. As of 2022, achieving a 1.5 degree limit is not impossible. However, the window is obviously rapidly closing. Electricity consumption for building operations, including heating, cooling, and lighting, represents nearly 55% of global electricity consumption. Buildings generate nearly 40% of global energy-related emissions, with 10% of these emissions coming from building materials and construction. And when you look at the facts like that, it's actually quite wild. Projections show the energy demand and related emissions of buildings may double or even triple by 2050. The building sector therefore has a critical role to play in addressing the risks of climate change. So changes in emissions over recent years are driven by a number of key trends. Operational emissions are all emissions associated with running a building, such as heating and lighting, and these have been increasing following a stable period between 2013 and 2016. This is due to the heightened use of appliances and HVAC systems. Households with access to these systems grew by 8% from 2010 to 2020. Usage of these systems have also increased due to more extreme weather events, very high temperatures, severe heat waves, and even cold snaps. Although overall emissions are still increasing due to energy efficient design and advancements in technology, building sector energy intensity, measured as final energy use per meter square of building floor, has actually been decreasing continuously since 2010. Approved Document L provides guidance on compliance to energy efficiency requirements for dwellings and non-domestic buildings in the UK, including limiting heat gains and losses and calculating target energy efficiency rates. So the main driver of future emissions is the increasing need for housing with electricity and cooking facilities for billions of people. The global building floor area is expected to double by 2060. This is equivalent to adding an entire New York City to the planet every month for the next 40 years. The way in which these energy demands are met will significantly determine future carbon emissions. So embodied carbon refers to all of the CO2 emitted throughout the life cycle of a material, product, or building. For buildings, this is all the emissions associated with the materials and construction processes throughout the life cycle of the building. This can be considered a building's carbon footprint before it becomes operational, all the way through to end of life. Despite making up around 10% of all global emissions, embodied carbon has typically been overlooked. Most of buildings' embodied carbon emissions occur upstream of the building itself and are largely invisible to the architect or builder. Given the scale of new construction projected over the coming decades, it is critical that embodied carbon is considered in the design and construction of buildings that are being built today. So the World Green Building Council, WGBC, which some of you will know, has produced an embodied carbon report for coordinating action to tackle embodied carbon. The targets laid out by the report are, by 2030, all new buildings, infrastructure and renovations will have at least 40% less embodied carbon compared to business as usual. By 2050, new buildings, infrastructure and renovations will have net zero embodied carbon. Net zero embodied carbon basically means that no carbon is emitted over any stage in a building's life cycle. So the construction of a building, its usage over time, and its eventual demolition create long-lasting impacts on the environment. A life cycle assessment, LCA, is a standard way of measuring these environmental impacts, including the carbon emissions associated with each stage of a building's life cycle. Emissions associated with the product and construction stages up to practical completion are referred to as upfront embodied carbon emissions. They can also be considered as today emissions, emissions that have been released at present. So these include emissions caused by the extraction and processing of raw materials, the energy and resources used by the factory for manufacturing of the product, the transportation of materials to site, and the construction of the building. Emissions associated with the materials and processes needed to maintain, repair, and refurbish and replace materials in the building are called use stage emissions. These are separate from operational carbon emissions, which are associated with the energy and resources needed to operate the building in its use stage. So emissions due to demolition activities and disposable or recycling of materials are referred to as end-of-life embodied carbon emissions. And then the upfront, use stage, and end-of-life emissions make up the whole of life embodied carbon emissions of a building. So, what are the main sources of embodied carbon? In terms of materials, concrete, steel, aluminium make up a large majority due to the carbon-intensive processes used to make them. Glass, plasterboard, and paint also provide substantial contributions. In terms of a building's structural elements, foundations and frames often represent the biggest contribution. The enclosure is also significant as it represents around 15% of the embodied carbon of a typical commercial office building. This includes the cladding, the windows, and insulation materials. Structure. So, carbon offsetting. So, what can we do in the meantime? Carbon offsetting is an important, rapidly deployable strategy that allows the building sector to mitigate its unavoidable emissions now until we transition to low or no carbon technologies. So, how does carbon offsetting work? A carbon offset is generated by an activity that either avoids, reduces, or removes GHG emissions from the atmosphere. These can be purchased and traded in the form of credits that typically represent 1 ton of GHG emissions. Carbon credits are generated from projects all over the world and purchased by companies who are interested in voluntarily offsetting their carbon footprint. Buying carbon credits provides a direct financial contribution to support carbon projects, allowing them to continue reducing emissions and benefiting the communities around them. So once a certified carbon credit is purchased, the credit is retired from the register, so it may not be used again. This provides full transparency and ensures the carbon credits are real, measurable, and also permanent. So for manufacturers, the World Green Buildings Council's Net Zero Roadmap states that from 2020, companies should have started developing carbon reduction targets with timelines set to achieve net zero embodied carbon by 2050. By 2025, manufacturers should have product-specific environmental product declarations, or EPDs, covering the top 40% of their product portfolio. By 2030, the environmental impacts of the entire product portfolio should be declared via EPDs. By 2035, all electricity for manufacturing and transport is from renewable or low carbon sources. And then by 2045, all forms of energy used in manufacture and transportation are renewable or low carbon. So, determining the embodied carbon of any material depends on the self-assessment and process transparency on the part of the manufacturer. So that's really crucial for all manufacturers, especially as for Ortex. So EPDs provide a robust science-based communication method for demonstrating the environmental impacts of products and services, including embodied carbon over their lifetime. To produce an EPD, first the category rules are selected for the product type, then their environmental impacts are calculated through a standardized life cycle assessment. This data is then verified and compiled into the EPD. The EPD provides a basis for comparing products and services, and they are registered and stored on free databases around the world. EPDs are an essential tool for evaluating environmental performance and selecting sustainable products for a project. So, for designers, the roadmap to net zero encourages designers and architects to begin integrating low embodied carbon material selection and building life cycle assessment at the conceptual design stage. By 2025, embodied carbon data for all building projects should be disclosed and stored in public databases. So companies should propose best practice embodied carbon targets for all projects and require low carbon materials. And then by 2035, the roadmap states design companies should propose requirements for all projects to be 100% net zero embodied carbon. So designing for net zero. Building designers have considerable influence through interventions from the earliest design stages where mindful decisions around embodied carbon can be made. They are in a good position to challenge conventional approaches and facilitate awareness with progressive design, coupled with high potential to influence their supply chain through requesting EPDs and product data and increase the demand for low carbon or carbon neutral products. So holistic whole of life design considerations have the most impact on reducing embodied carbon. Some design rules of thumb include reusing existing structures, so reusing and repurposing existing structures where possible. This can save between 50% and 75% of emissions compared to constructing a new building. Wherever possible, salvageable materials should be reused as their embodied carbon has already been emitted. And then through maximizing structural efficiency, that's a very hard word to say, efficiency, the use of structural materials can be minimized. So to summarize, we are currently facing a climate emergency, as we stated at the beginning of this presentation. The building sector emits a large proportion of global greenhouse gases and is uniquely positioned to reduce future emissions over the coming decades, where there will be substantial growth in the building floor area. We are also seeing encouraging reductions in the intensity of operational emissions, which will lead to a greater relative proportion emissions from embodied carbon. And if we are to limit global warming to well below 2 degrees, the building sector must meet net zero targets by 2050, where all new buildings, infrastructure and renovations will have net zero embodied carbon. So in order to achieve this, achieving these targets will require the integration roadmaps of relevant stakeholders, including the client, the project manager, the architects, the manufacturers and the building owners. Designers have a large influence through interventions from the earliest design stages, and this involves conscientious material selection of low carbon or carbon neutral products and holistic low carbon design approaches across all phases of a project. Manufacturers should adopt carbon transparency through publishing EPDs to inform decisions while actively reducing their products, embodied carbon and offsetting remaining emissions. The increased supply and specification of low carbon materials will help achieve the vision of a decarbonised future for the building industry and limit the impacts of climate change. And I think that's the end of the presentation. I'm not sure if maybe it's quite quick, but I hope that kind of wrapped up carbon in a nutshell. And I did mention carbon probably about 50,000 times, so I hope you are more well aware of the word. But if you have any questions, please let me know.
Thank you, Emma, for your presentation there. Really appreciate your time. And yes, now we're all up to speed on the carbon and carbon emissions, embodied carbon, life cycle stuff. Definitely, this is my time to remind the people in the room here with us virtually to hit us up in the chat functionality on the right-hand side, it should be. And Jay will find you there, and then I'm going to ask on your behalf some questions. I'm going to pay my MC privilege cards again, Emma. So we can ask you to turn off your screen and turn on your video so we can see you. But we got some Q&As coming in now. My first question is around how is Ortex Acoustics approaching what you've just laid out for us, and how you're approaching these big, juicy problems?
So it's obviously really important for us as a company to kind of follow everything I just spoke about. In 2021, we're really proud that Ortex Acoustics achieved carbon neutrality across all global operations, and that's quite a vast thing to achieve. So we're really proud of that. And that's across all our global operations and also includes all of our entire range of acoustic products. We also design for circularity. We've adopted a circular economy strategy that shifts away from the traditional kind of linear model of make, use, and dispose. We also, which I hope most manufacturers do as well, but we also embrace the core principles of the 3 Rs, which is obviously reduce, reuse, and recycle, and examine how to minimize waste, generationally, and creatively repurpose materials to extend their life cycle. We have a lot of products that we've recently launched that actually close the full loop, and we can completely recycle our product at end of life.
Wonderful. So that's a demonstration of not only your commitment as an organization and a brand in terms of products, but also everything you just kind of detailed. But you did put in your presentation that line about designers are the best place to drive change. Right? And I was wondering if you could expand on what you see the biggest challenges or maybe hurdles, turn them into hurdles, right? That designers specifically can or are facing, and then can work the ways to get over.
So I think I obviously work with the designers on specification at specification stage. So we always push our products and really reiterate the importance of sustainability. And I think the designers definitely adopt our, thought process and want to specify the most carbonless product, should we say? Expensive. So it's more about educating the client and also to main contract stage, importance of sustainability. And a lot of projects now we see of the brand well, LEED, all of these kind of accreditations, which we really assist with from using our products. And also, I guess one of the newest products that we've launched is a product called SpinFix, which is essentially all of our offcuts from our material goes into a big chipper. It then gets injector molded and makes fixings, which I'll actually show you here, which is made out of 100% recycled product. This is then used to fix our product onto the wall. Let's put that back. Which is kind of revolutionary for us, and it's actually more cost effective than typical adhesive. So that's kind of a huge
Fantastic.
hurdle that
Thank you,
we've
Phil.
managed to jump. Yes.
Again, demonstrative. So that's fantastic. We have a couple of questions now from the community. So if you don't mind, I'll just read it verbatim so I don't get it wrong and just
Yeah.
quote who's asking as well. I'll start with the last one that came in, which is from Dennis, asking specifically, do you have products that target BREEAM scoring credentials, which are BREEAM scoring credentials?
Yes, so great question. As I just mentioned a second ago, so all of our products help achieve BREEAM, WELL, and LEED. And because our products are made from the same material, it doesn't matter which product you're specifying, it's all going to equate to the same accreditation.
Fantastic. I know there's some calls for asking for your copy of your presentation, which people can email you. I'm sure that you could share
Yeah,
some of your
absolutely.
sources and stuff. Fantastic. And then we got a question here from Phil, who is asking, are carbon credits traceable in that there is transparency about where investment is spent?
Yes, yes. So to my knowledge, all the carbon credits are fully traceable, and it's also traceable online as well. There's databases online that everyone can access to see actually where the carbon credits are being spent, essentially.
Brilliant. Thank you for that. So again, any other final questions, please just up in the chat. I'm going to come in with the question around the World Green Building Council that you were quoting in terms of the different areas of expectations of targets around 2030, 40%, and net zero by 2050, which is 25 years away, as we all know. It's coming up fast. How hopeful are you in terms of reaching those targets as an organization, but also what you're seeing out there with your partners and other agencies who are trying to achieve this? Do you think it's achievable?
I mean, I hope so. Definitely from Ortec's perspective, we have already well achieved everything already. So we've had full transparency and full EPDs on our entire product range. I think like 8 years ago, we've had these on every single product, where it's actually only legal to have them by, I think I mentioned 2025, I think it was, but we've already had them for years and years. We're also carbon neutral, which is amazing. And we just hope that other manufacturers can take the time, and it really does take a lot of time to invest and fully look at your manufacturing processes, operational processes. It's quite a huge step to become carbon neutral, and it's taken us years and years and years, but we've been tracking and monitoring since the 90s. And we, as of 2021, became carbon neutral. So we just hope that other people and other companies in the industry are kind of following suit and doing everything they can to be as sustainable as possible.
For sure. And to wrap this up, a question like I did with Lewis about the future of both your product range and your attempt to continue to be, I suppose, a key leader in the industry around carbon emissions, around embodied carbon and becoming carbon zero yourself. What's the future hold there?
So very exciting, Ortex. There's lots of things that are kind of coming up in the works. We've recently launched a new product, which is our ceiling grid tiles, which is essentially developed to use in all retrofits. So as I mentioned in the presentation earlier, it's really crucial that we try and repurpose buildings as much as we possibly can. And we're using our recycled material into existing ceiling grids, which you'll see over thousands and thousands of offices, you know, the typical 600 by 600 metal ceiling grid. And that's where we can put in our ceiling grid tiles, also change the design, help with the acoustics, but you're using recycled material and you're repurposing an existing ceiling grid. So that's something that we've done recently. But I guess maybe in the wider picture, there's only so much recycled plastic that there will be. One day there might not be as much. So we're doing everything we can to use all of the recycled plastic into our materials at the moment. But maybe it's about thinking about a different fiber that's 100% sustainable. And that's something like
Well, we
watch
did
this
have a
space, I guess.
sorry. Well, yeah, of course. Right, keep pushing
Yeah,
the envelope in a good way, I think. So there's a cheeky question
absolutely.
that snuck in just as I was wrapping up. If I can be cheeky and ask, which is again from Dennis asking, are
Hmm.
your products imported or manufactured or manufactured in the UK?
So great question. So we are a global company. We have manufacturing in the UK, in New Zealand, where the company was actually founded, in Australia and in America. And we in the UK produce and manufacture all products for UK projects and also Europe and Middle Eastern. And then it's the same in projects that are more in New Zealand. Then everything will come from the New Zealand manufacturing, and the same in America and Australia.
Superb. Fantastic. Well, thank you for your time, Emma. You've given us a shot of kind of hope and inspiration and like I say, leading the charge there as an organization. So I appreciate both your time, your candor and openness today, and we'll put your contact details up in a bit. But thank you very much, Emma. Really appreciate it.
Amazing. Thank you so much.
Cool. Well, thank you, Emma, and thanks to Vortex as well. Like I say, leading the charge. We do have, again, if you want to reach out to any of these good humans that we're presenting to you today, I think we have a slide that we can put up and you can grab those contact details. And again, if you have requests specific for presentational or specific slide information or reference points that are quoted within slides, I'm sure these good humans will be very happy to go, yes, that was a reference made from that kind of quoted area. So please reach out and we'll put that up one more time towards the end as well so you can grab those contact details. We're going to take a little bit of a break, but before we do, two quick things. One, we want to give you a nice little giveaway. So we're going to have some fun now. I'm going to ask you a question and the first person to answer the questions in the chat gets this, which is a wonderful book by an equally wonderful and impressive young man called Tom Candig. We had the pleasure of hosting out in New Zealand, and I got to sit on the stage and chat with him. He's a delight and wonderful kind of architect, architectural designer doing amazing work. And his book is up for grabs. So I need to ask you a question. Then the first person to answer this question in the chat will get this book, and we'll sort it out with you. And my question comes from the first presentation, which was Lewis's. And he spoke from a company called Abodo, which is this Abodo series experience. So I'm going to ask you, when was Abodo founded? What year specifically? So what year was Abodo founded? Hit us up in the chat. We'll give you now 5 minutes to have a bit of a break to fill up your beverage. When I come back, I'll announce the winner if you haven't already seen. And to take us into that kind of break, we're going to do a bit of a movement break, and you can pop while you're filling up your beverage, but I'll see you in literally 3.5 minutes. Thank you very much. See you soon. So welcome back. Hopefully you had a good groove there with a fellow beanie wearer that I am as well. So we got a winner for the book. So thank you for participating. So many people answered in the affirmative in the right way. And we can now say that Daniela Pirelli is the winner of that book. Jay will reach out with you in the chat, and you probably drop her an email and she can get that book to you in the magic of postal service. So thank you very much for participating in that. Always good to give away stuff and have a little bit of a movement break as well. So let's get into the final speaker now to close out this wonderful Abodo CPD series that we're launching here today. It's great to have you with us. Hopefully you're learning lots, taking lots of notes. And again, we've got the chat room there to share ideas, thoughts, links that you'll find in throughout the talks related, obviously. And then there's an opportunity to ask questions, which I'll do on your behalf at one more time. And we have Tim coming up. So I know we have Tim already here joining us, so I don't have to double check. And let me give him a proper introduction. So Tim Robinson from Son Studios is joining us here to close out the Abodo CPD series, and Tim graduated from Leeds University with distinction and went to work for an award-winning UK practice specialising in refurbishment, workspace and educational buildings. For a short period, Tim was one of the youngest qualified architects in the UK and was quickly promoted to associate at the age of just 26. Tim has designed and led multiple award-winning projects with a specialty in high-quality refurbishment and expertise in combining creativity and practical craftsmanship. Tim founded SON in 2024, so still a baby, with co-director Phoebe Lang, and it's great to have you with us, closing us out on this afternoon. So Tim, over to you.
Great, thank you very much. So thank you for the introduction, very kind of you. So hopefully you can all see my screen. It's all running fine. So yeah, so I just great introduction already. But yeah, my name's Tim. So I'm a director, and I'm also an architect. And we run just want to do, I suppose, a quick overview, I suppose, of the studio that we run together. So myself and Phoebe, like you're saying, very new, only started this year, but we're already an award-winning studio. We work across multiple sectors, from private residential, workspace, retail, hospitality, and also one-off installations and really some sort of experiential design as well. So, and I think we are a new company, but we are really passionate and innovative. I really love working collaboratively with our clients and craftsmen to deliver really high quality designs, really rich in materiality. And we would think this multidisciplinary approach is key to really allow us to deliver unique and personalized solutions that really resonate with the client's visions and needs. So a very short bit about us and our company. So what I wanted to talk about today was, there's obviously Emma's really helpfully given an overview of carbon, and obviously an introduction as well to embodied carbon. But what what we think always gets forgotten is how can we approach this in the small scale? So there's all the these big ideas about how we can impact on large scale buildings, but a lot of the times the smaller scale, the smaller aspects of having an impact is forgotten about. So what I want to do today is I want to talk around what it means, or what is embodied carbon, and what are the best approaches. Then I'm also going to showcase one of our projects and how we have approached looking at small scale elements and how they can actually have an impact. So I know, like saying, Emma's touched on this previously, but I think it's important to point out the impact of the carbon emissions and their impact on the built environment, and breaking these down into three different scopes. So each of these scopes is defined by the Greenhouse Gas Protocol, and there's three different impacts of how the built environment has an impact, I suppose, on the amount of carbon emissions it's emitting. So the first one is scope 1. So this is direct emissions. So these direct emissions, this covers greenhouse gas emissions that occur from source owned or things which are controlled by the company. So examples in construction or the built environment would be emissions from on-site construction machinery, excavators, bulldozers, cranes, on-site heating, so emissions from heating systems used on construction sites, obviously particularly during colder months, and company-owned vehicles as well. So emissions from transportation vehicles owned by a construction company, such as trucks used to transport materials to the construction site. So these are specific direct emissions. Then the scope 2 is indirect emissions. So emissions being released into the atmosphere associated with your consumption of the purchased electricity. So examples of these being so electricity consumption on the site, so emissions associated with the electricity used to use power tools, equipment, lighting, And then also electricity for temporary offices. So things like emissions for electric use in temporary office structures set up on a construction site, such as trailers for project management staff. So these are all kind of indirect energy sources or a kind of specific scope on a construction site. And then scope 3 is kind of other indirect sources. And kind of step 3 covers all other indirect emissions that occur during a kind of company's value chain. This is often the most significant source of emissions in the construction industry. So other examples of kind of scope 3 items would be emissions from material production. So production of construction materials like cement, steel, glass, bricks, or any other material which is kind of used within the construction of the building. Also kind of transportation and waste of materials and waste. Employee commuting as well is in this scope. Also kind of subcontractor emissions, so emissions associated with subcontractors' activities, including their use of materials and energy. Then also kind of end of life treatment of materials are also involved in this kind of scope 3. So emissions related to the disposal of recycled materials after the construction project is completed. So there's quite a lot of aspects which are included in this kind of scope 3 item. So what we kind of can gather from that is that there's a lot of aspects which are kind of involved in this kind of scope 3 item. And then I suppose one of the questions we get asked a lot as an architect is kind of how can we reduce that kind of, I suppose, that the overall embedded carbon, but also kind of that kind of scope 3 item, which is probably the aspect that we will have the most impact on. And what we think is the kind of the best approach and the best way that we approach project is we kind of consider it as a kind of fabric first approach. So what is the impact, or what will have the most impact? And it's probably as architect designers, it's considering the selection of products and lowering the embodied carbon of the amount of what is involved in the selection of them products. So put simply, this kind of fabric first approach is what involves, it kind of involves prioritizing the building envelope first. So walls, roof, floors, windows, doors, to create a high performance, energy efficient building. This approach kind of considers the building's fabric as a primary means of reducing energy consumption rather than just relying on mechanical or electrical systems. So this is kind of the best way to approach a building initially, is that especially as kind of a refurbishments of buildings, instead of putting in kind of lots of high energy intensive mechanical systems, it's kind of thinking about how can we deal with the fabric first, and this is the kind of approach that we like to do initially, rather than relying on mechanical or electrical systems to reduce the kind of the overall carbon usage of a construction project. But having a kind of fabric first approach means that the material section obviously becomes even more important. So, like I say, I know kind of Emma's mentioned or kind of touched on this before, but obviously the actual material section means that the actual embodied carbon within that material becomes even more important. So just to clarify again, what actually is embodied carbon? So embodied carbon is all the CO2 emitted in product materials, and it's estimated from the energy used to extract and transport raw materials, as well as emissions from manufacturing processes. So the embodied carbon of a building can include all the emissions from the construction materials, the building processes, all the fixture and fitting inside, as well as from deconstructing and disposing of it at the end of its lifetime. I think there's ways that you can kind of clarify this or assess this, and obviously there's many kind of analysis or kind of environmental assessment methods. Obviously BREEAM, LEED, SCAR are all kind of methods that we use to kind of assess I suppose the environmental or the environmental impacts you are having on your specific project. And then I suppose also it's kind of thinking about what impact, I suppose the question is what impact does this have? So these pie charts here are kind of actually quite interesting. So these pie charts illustrate the indicative relation between operational and embodied carbon emissions for kind of 3 building typologies. I suppose what this really shows is that you have the embodied energy or the embodied carbon aspect of the overall life of a building is actually the significant percentage of this kind of pie chart. So looking at an office, warehouse, and a residential, you can see that the kind of the orangey brown kind of percentages are the kind of the embodied aspects of the building. And over a 60-year period, this has got obviously a significant impact. And it's probably the thing that we should kind of considering the most, and especially considering kind of initially, rather than trying to fix things later on with kind of mechanical systems. And I suppose also just to kind of consider in this graph as well is the residential aspect as well. You see that whole life embodied emissions practical completion, this kind of 51%, is a significant percentage. And I think it's also important as well, it's something that we as architects and designers can actually significantly have an impact on. So therefore, this kind of reinforces the need to consider reduce embodied carbon in our kind of buildings. So what I wanted to do is a kind of showcase how we've done this on a kind of small scale. So I wanted to show you a project that we've been working on. So what we've done here is kind of zooming in onto a project that we're working on. This project is located in London, in Hackney. And as you can see here, I'm just kind of rotating around. It's a kind of traditional Victorian terraced house, located on a busy market street. And the client had a lower ground floor flat within this building. I'm kind of zooming again. And I suppose what they were asking for is they were wanting to see how they could improve the kind of quality of space that they wanted to have within the property. It was previously a very restricted single 1-bed apartment. It did have a really kind of great garden, but it had very little kind of connection to that garden. So this is the property here. The kind of red light denotes the extent of the site boundary. And the photographs on the right-hand side showcase the existing property. So for people in London, very typical kind of 1800 to kind of 1900 Victorian kind of terrace house. Obviously, very little kind of connection to the garden. It's just got an existing kind of courtyard space. Very small accounts, kind of natural light as well into the space. So kind of one of the key aspects of the brief from the client was obviously kind of increasing that kind of connection to the garden, but also kind of additionally kind of adding an additional bedroom. And also that key thing of they were kind of keen on kind of sustainability, but also having quite a natural and organic feel. It's quite a busy street at the kind of the front of the house. So they really wanted that kind of that feeling of kind of escape from that kind of really busy central street, to kind of have that escape so they can move to the garden and have that inside outside connection with the kind of kitchen living space, but having a great kind of use of natural light and kind of natural materials. So what we did is we approached the project, and this kind of just little diagram gives a very simple kind of very simplistic form of kind of the strategy and approach that we took. Is we took out the lower ground floor, or the kind of lower ground floor element below the outrigger, and then aligned and kind of slightly chamfered this kind of new extension to align with the neighboring buildings, while also interjecting kind of roof lights into the space to kind of get as much light as possible into the space. And in terms of kind of plan format, so all of the darker grey elements are the new aspects. So from, as you can see from that previous diagram, we removed out the lower ground floor area and reconfigured the kind of that existing area below the outrigger, and reconfigured to kind of create a new kitchen living space with views and access out into the garden. Light and height was also kind of a key element for us in this space, only a kind of really kind of small flat. So what we did is we lowered the floor in the main living space, and as well as that, we also lowered the floor even further to create a kind of nostalgic 70s sunken sitting area along this window side here, which allows you kind of have views out into garden. And also there was a kind of really beautiful apple tree, an existing apple tree, which meant you could actually sit in this kind of sunken pit and sat below this apple tree. Another aspect as well, kind of key element, was kind of about joinery and storage, and kind of having a kind of making a kind of clean space. I think especially in a small flat, is kind of storage and having areas that can hide elements was really key. So along this kind of full back wall, we had a full storage wall, which allowed you kind of conceal a kind of kitchen, pantry, and storage. But also it's kind of had a dual use as well. So we introduced a second bedroom internally, as well as internalizing the bathroom space. We centralized a second bedroom internally, but had a roof light from above, which was the bed was kind of located so it could have the lid on the bed and kind of views out towards the sky by a vented roof light. So it meant that we could kind of squeeze in a second bedroom, but not utilize any of the kind of valuable external facade with these kind of views and connections out to the garden. So, like I say, so this is the project that we were working on. This was the kind of the brief that we were given. So then the questions we had was, how could we implement low carbon strategies into quite it is a very small scale project. So we were thinking that there must be certain ways that we can help reduce embodied carbon within this project. And we came up with kind of, I suppose, 5 key aspects. And it's kind of 5 key ways that we kind of, or elements that we try to implement on smaller kind of scale projects. So first one, use of natural or carbon materials. Second one, local sourcing. Third, sustainable construction practices. 4, design for longevity and durability. And 5, for aesthetic and functional integration. So what I'm going to do is just showcase how we've done this on this project. So the first one, very obvious, use of natural low carbon materials. So the actual material choice. So on this project, we went for a lime plaster. So kind of project predominantly features the use of a lime plaster. It's kind of a traditional material with a lower embodied carbon compared to modern cement-based plasters. And lime plaster has kind of the ability to absorb CO2 as it cures, slightly offsetting its carbon footprint. As well as that, we also use a kind of lime wash finish internally, as well as the lime plaster externally. And lime wash is a kind of basically a thin layer of limestone that dries on your wall by taking it and actually takes in carbon dioxide from the air as it dries. Also, we really wanted to kind of use natural finishes. Really simple, but kind of natural finishes which felt kind of organic and didn't feel kind of contrasting to the kind of I suppose the external the greenery of the garden. So other natural materials and finishes are used throughout the project, which generally have a lower embodied carbon than synthetic alternatives. So prominent use of FSC sourced timber for the windows, floors, joinery. Second aspect, local materials. So obviously we kind of work in a kind of global economy, and especially kind of in the UK, there's not a significant amount of actual materials, construction materials produced in the UK. So we tried really hard to try and source either from the UK or either from the EU to try and reduce the amount of kind of travel, that these products use. So UK, EU products that we used. Also, we're really trying to use kind of local craftspeople. So all the joinery was kind of produced by a local craftsman. It's kind of the custom inbuilt sofa. So a lot of the aspects of this project were actually kind of custom to the space because it was so small. You keep really quite custom joinery elements or custom furniture items, which actually meant that we could use local craftsmen and local craftswomen to help kind of ground the project in its locality rather than sourcing either joinery or furniture items globally. So really trying to reduce down where we were getting them from. All timbers, like I say, sourced from FSC forest, European oak. Paints were low VOCs, obviously kind of really important as well. Third point is kind of sustainable construction practices. So traditional handcrafted techniques. So there's utilizing traditional handcrafted construction technique can often result in kind of less material waste and more efficient use of resources, kind of compared to kind of mass-produced and standardized construction methods. So standardization is obviously kind of great, but we kind of were really kind of wanted to use kind of handcrafted traditional techniques. So although the kind of the building form that we kind of wanted to create was kind of a tropical modernist feel to it, the use of lime plaster, although in a modern application, has been used in the UK since the 14th century. Also kind of the timber windows are kind of from a UK-based company who traditionally supply kind of very traditional sashed windows, which kind of use across a lot of the kind of Victorian terrace houses. So really utilizing local skills and knowledge and trying to use local materials where at all possible. And another one, which I suppose is kind of can be forgotten about or kind of be pushed aside sometimes slightly, we find that depending on the client, is that we really kind of drive for design for kind of longevity and durability. So how can we make our designs and our projects actually be durable and long-term and last a long time? We really want to kind of limit, kind of stop a building being kind of designed and ripped out within a kind of a few years. That's not what really we're about. We're about kind of longevity and providing long-lasting, durable materials, which reduce the need for kind of frequent repairs and replacement, which therefore in turn lowers the long-term embodied carbon of a building. Also, we really want to kind of reduce the amount of kind of plastics and laminates in a building. So all of our timber is kind of either solid kind of European oak, or we use kind of veneers. So no kind of laminates in the buildings, kind of natural terracotta tiles, kind of durable, kind of traditional material, which we use in the bathroom, as well as kind of we used kind of marbles and terrazzos, kind of really kind of traditional techniques and traditional stones, but obviously known for being kind of durable and long lasting. And I know kind of concrete obviously kind of gets a bad rap, especially in kind of embodied carbon. But what we wanted to do is we knew that there were certain areas where we knew that kind of get harder amounts of wear and would need to be more durable. So areas such as, if you can see around the kind of pivot door, is we've got kind of a concrete transition strip, or we've got areas where some of the lintels are kind of or the copings are kind of made in kind of concrete elements, which gives us the durability that we need for the project. So reducing the amount of it is kind of key, but using it in the key areas, I think, is also kind of what we wanted to do to increase that durability of the building. And also just kind of a fun one, but I think we like to introduce planting within elements of joinery, which means obviously kind of increasing the amount of biophilia in the space, getting that real feel of inside and outside, but also kind of improves the air quality of the space. I think also by having it within the actual items of joinery, it means that it kind of forces the client to have planting within their building or property. So instead of having just in a plant pot, which they can move around, and if a plant dies, they've got to get rid of, it really integrates it and really embeds it within the actual architecture. And the last one out of these aspects of how we've lowered embodied carbon is quite a strange one, but I think is important, is aesthetic and kind of functional integration. So designing with materials that serve both an aesthetic and functional purpose, project avoids the need for additional decorative layers of treatment, thus reducing the material use and associated embodied carbon. So we always try to, in all aspects, is try to use materials which can celebrate that actual material: timber, wood, stone. They all kind of are the actual natural material. And I think trying to create a project which celebrates them materials rather than trying to decoratively cover them up is a great way of reducing the actual material use within the building. So I think that's a really great way of trying to utilize the kind of, or having beautiful space, but really actually making sure that you reduce the amount of actual material and product you put in space. Obviously, eventually means that you can actually reduce the overall embodied carbon within the project. So hopefully that gives you a very quick overview of how these kind of small scale measures can collectively have a really big impact on the overall industry. And hopefully it shows how we've done this on a small scale project, and I suppose how you can as well. Great, thank you very much.
Thank you, Tim. Really appreciate your presentation and sharing your insights there and your projects. If we can ask you to turn off your screen sharing and turn on your video so that we can do what we've done with the other two speakers, which is to both see you and also ask questions of you. That's my cue to remind people to ask some questions so we can ask you. I've got one to kick off with, which is what you were saying right at the end when you were sharing beautiful project, your insights and those steps that you took. I'm just going to ask you a quick question about scalability around that. Obviously, you were talking at a small level, but do you see the constraints, liberate your imaginations, but the constraints almost kind of actually lend itself nicely to that deep consideration, that utilitarian approach that you took, right through to, well, actually, this stuff can maximize and scale out. What are your thoughts about that?
Yeah, I totally agree. I think I wanted to discuss around small scale because a lot of the time these items are spoken around on large scale. I see a lot of these presentations where people talk around how can we reduce embodied carbon. They're all talking around the kind of 45-story kind of like residential building or kind of a big office block, and I think to the majority of people that's totally alien to kind of what they're doing. The majority of probably people are interested in kind of smaller scale developments and how that can have an impact. The bigger companies will definitely be, or should be, hopefully doing that on larger projects. I think the interesting bit is trying to not forget around smaller scale projects where we can still have an impact. And obviously we work across kind of a range of scale of size of projects, but I think it's not to forget about it when you have a tiny little project, is not to be like, well, it's small, let's not worry about it. It's not going to have much of an impact. Let's focus on this bigger project, which will have a bigger impact. It's kind of thinking about it across all scales and sizes.
Love that. Love that. And that showed my biases around scalability. You brought it back to, no, this is so important. And I'm going to now read, if that's okay, from the chat questions and ascribe humanization to them as well. From perspective, we've got 3 already dropped in. I'm just going to start with, I think that's Bob. Yeah. Did the client come out at the end of this project feeling surprised that all the carbon benefits came with a fantastic piece of design, or did they get more than they expected?
I'm hoping to get more than expected. I suppose that as architects, we always hope to challenge and surprise. And I think it's the key thing is to kind of take a brief and develop it to something that they may not know what they think they want. It's a stranger as an architect. You've got to kind of take on and accept aspects of the brief, but then also kind of say, well, actually, there's certain ways that we think you could do this, and we think that it's probably going to help you in the long run. So I'm hoping that it's probably a surprise, and also I suppose just there's got to be trust. There's got to be a trust aspect there, that trust your architects and your designers, because they have they've been training for a long time, and they've got kind of good knowledge and skills. I suppose just as a promotion of architect designers, that they will hopefully help and I suppose guide clients to the right result, and hopefully end up with a great product that surprises, but also answers all the kind of the brief requirements as well.
Mm. And we got a specific question about that from, I think, who was it again? There we go, Craig, which kind of aligns to it. How do you approach the topic of, how do you approach the topic with the client of specifying more expensive, durable products / locally crafted and bespoke furniture versus cheaper off the peg or off the shelf?
It's not an easy. That's not an easy one to answer. It's always going to be. It's always a challenge. It's always a challenge to kind of nudge people towards lower carbon projects, which aren't always more expensive, but are sometimes, being completely honest. I think the thing you try and do is the thing that we always try to do is think about the best use of spend. And it's trying to focus in where you want to spend that money. So there's aspects on the kind of the projects we're just showing where we use very kind of simple techniques. The kind of the construction of it, very basic. It's very simple. And it's sometimes trying to not overcomplicate certain aspects of the build, but then focusing your budget maybe on specific elements which will have a bigger impact. So maybe saying to a client, well, maybe we'll simplify this element of the building, but then let's focus our budget on this, because it'll have a bigger impact on whether the quality of the project or the reduction of the kind of the embodied carbon or amount of carbon output of the project. So it's trying to think about where is the best spend, and trying to, I suppose, encourage your client to guide them towards the best spend routes, rather than just being like, you're going to spend expensive on everything. It's like trying to choose the correct area or the correct thing to spend the money on.
Superb. And that speaks back to what one of your framework points around designing for longevity and durability, right? So yeah, it might cost more upfront, but the longevity of this, you're not going to replace it or having to replace it. It's more durable. So
exactly.
Thank you. There's a question, there's a three-part question here from Phil. So forgive me if I breathe in while I speak. Do you use natural insulation materials such as hemp-based or wood wool? If so, do you know of how to assess their U value within a wall build-up similar to other PIR? Also, do you find builders amenable to their use?
Yeah, sure. So that was about yes, they are. We have used natural kind of insulation materials before. U value calculators. There's quite a lot of them online now. Or even what I'd even do is any kind of hemp-based or insulation. I'd contact them directly, and they will be able to kind of provide you the U value build-up for your wall. So yeah, I would, as always, highly advise using natural-based insulation products. It does, I suppose, the issue sometimes is that it does increase a lot of time can increase kind of wall buildup. So that is obviously kind of something you need to kind of consider, depending on the size and scale of your project. If you're dealing with kind of a very tight project, it can be a limitation, but something which is maybe something that we should possibly discuss with the client. And the second part of the question was,
Yeah, the second part of that is how do you find builders amenable to their use?
I think the builders are pretty, I'm sure, depending if you've got a good builder, I'm sure they'll be happy to work with you. I know good builders like to learn, so they like to learn new skills. So if you've got a good contractor, then they'll definitely be interested in learning new techniques, because you'd be hoping that they'll be using these techniques to go forward. So yeah.
Fantastic. And we have another one just come in from Eileen. What type of windows would you recommend, which are more environmentally friendly? And would you recommend aluminium?
Yeah, so aluminium, timber, so you might have seen we do like to use timber windows if possible, because they do have a lower embedded carbon than an aluminium window. But aluminium does have its benefits. It might have a very slightly longer lifespan, but a lot of the new I think you've kind of mentioned previously obviously on your presentation as well, is that the treatment of timbers now means that we can actually have long-term durable timber products, which will achieve the required U values for timber windows and doors as well, as equally as an aluminium window would achieve previously. So I think it's really interesting seeing the development of these kind of timber windows. Obviously, it's quite a traditional look, even if using kind of contemporary manner, but these new techniques of creating these kind of timber windows and doors are actually achieving similar U values to what you get with an aluminium window.
Wonderful.
So it's all about.
And you mentioned
Yeah, that's okay. Go on, sorry.
I was just going to ask you a little bit of a question around. You mentioned right at the beginning of your presentation that you serve many sectors. You are cross-sector in that regard. You don't have a specific industry you serve. And I was going to ask you, like, what have you learned from other sectors when it comes to this topic of thinking small around carbon embodiment, carbon reduction, use and stuff? Was there anything that you have pulled from different sectors and you just think they should speak to each other?
Yeah, I have actually. There's I've previously, so our previous practice, we worked on a lot of higher education and university buildings, and what we find is we really try to design for thinking I suppose, long-term future in mind. So on a lot of them kind of projects, we were doing a lot of kind of refurbishments, and there'd be quite a lot of churn. So there'd be kind of, depending on the requirement of the space, it might change every 3 to 5 years, depending on the usage or the courses. So they had quite a lot of change. Oh, we need to change it. We need to make it suitable for this use, or we need to change it, make it suitable for this use. So what we really were always trying to do was trying to, I suppose, future-proof it, to say, well, actually, if you provide a design which provides flexibility, then you're not going to need to kind of completely strip it out in 5 years. Yes, the use might change, but a lot of the basics, a lot of the background elements of the scheme can still be used. And I think that's a key thing, is kind of thinking about the long-term use of it and trying to think. We always kind of say designing as a master plan. So if you have that end goal, or that thinking of kind of 20 years time, how will they be using that scheme? Not just thinking, let's just do 5 years, bish bash bosh, rip it all out and start again. It's kind of thinking, is there elements and things that we can keep and provide for the long term? And then there might be small tweaks that you need to do in the short term, but thinking about that kind of master planning, long-term view rather than a kind of a short scale view. I think that's kind of something we've definitely learned from other sectors.
Well, we close out like we will with all the interviews, the Q&A sessions about the future. And what are you working on the horizon that you're getting excited about?
Lots of exciting stuff on the horizon. So we've got a lot of kind of small scale residential projects. So we've got a lot of them kind of coming through. We've also got some kind of retail, and I think we've also done, like I say, we also did some work with Ortex as well. We did a one-off installation using their products as well, which we did during Clerkenwell Design Week, which is on our website, which you might want to check out, which is pretty fun. So yeah, lots of exciting things and lots of a range of things on the horizon.
Superb, Tim. Thank you for your time today and taking us out of this new Abodo series event for CPD. So thank you very much for your contribution today. Take care, Tim.
Thank you very much.
Cheers. So that was Tim, and I was our final speakers. Hopefully you've taken a lot of notes and taken a lot away. Before we let you go into your day, we got a couple of updates just to share with you. The first one being that the next event for this series will be on October the 4th. So if you can get your diaries out already and just slap that in, October the 4th, starting at 10 a.m. And we've already got some special guests lined up, as you can see from Sean Taylor there from Team Green. Might even have someone else coming in, which is very exciting. But we've also got another event as part of the Teulo Abodo network thing, which is the Sip and Sketch event on 10th of October. Now, you'll get all this information in the email follow-up after this event as well. But just for your diaries, maybe put a placeholder for the 4th and the 10th, and that's going to be an in-person one on the 10th as well. So that's going to be a bit more exciting as well. But all that will be sent to you. It leaves me now to say thank you to all the people involved, your good selves. Over 300 people signed up to be here today, so you're part of a much larger network. Jay in the chat room there, and also Harley producing, but our speakers, obviously. So that was Tim, that was Emma, and that was Lewitt for their contributions today. Hopefully, you've learned a huge amount, and you've got a kind of a book brimming with notes and things. We're going to put up, just to finish off, the contact details for everybody, so that you again can be reminded of who to contact. So you might want to take a screen grab of that if you haven't already, or note them down, or jump on LinkedIn and add these good humans to your network and thank them and reach out and steal their ideas, because that's what we're all about. So that was Designing for a Better Tomorrow. We'll see you on October the 4th if we don't see you before. Go well, good luck, and be good. Take care. Bye.